Transformations. What are transformations and what effect do they have on an object? Well, when we talk about this, I'd like to mention a YouTube video that I know about that some people might want to take a look at. It's called Transformation Style, and it's really kind of catchy. It'll get stuck in your head as well, but it talks a little bit about transformations. I'm going to play it just for a second. As you can see, it's pretty catchy and it's got some animation to it. So it's really kind of clever. So that's going to be attached here as well. So if you want to take a look at that, you can. Let's kind of get down to what they were talking about, though. They were talking about a transformation is an image change. It describes a change in the position, size, or shape of a figure. So a translation we could call a slide. A reflection we would call a flip. And a rotation we would call a spin. Now let's take a look at these one at a time, but let's get some vocabulary down first. We always start with what we call the pre-image. That's where we start from. And here I have a 5-sided figure labeled A, B, C, D. And then I have down below there a dotted image, which says the word image, and then A prime, B prime, C prime, D prime, and E prime. That kind of shows us a difference between the pre-image and the image. The pre-image is where we start from, and the image is where we end up. So let's take a look at these things one at a time. Now, as I mentioned, a translation is a slide of a figure to a new location. So let's try and see how we would move this to 6 units left and 5 units down. So what we would do is we would take each point. So let's start here with this point A. And we would move it 6 units to the left. So we start counting boxes. 1, 2, 3, 4, 5, 6, and then we'd go 5 units down. 1, 2, 3, 4, 5. And this would be the location of our new point A, which we will call A prime. We'll do the same thing for each of these points, where we'll go 6 units left and 5 units down. And every time we do that, we're going to put a prime sign next to the letter so that we all understand that this is not the original image, but the image transposed or translated or slid around. Okay. And then, like I said before, we were going to try to use dotted lines. So let me see if I get a dotted line here. And we want to make our image with dotted lines so that if somebody was looking at our drawing very quickly, they could see the difference between the image and the pre-image. Now let's talk about how these ordered pairs fit together. Let's write this down here for A. If we start with A, we notice that the location of that point is 3, 4. The location of B is 4, 3. The location of C is 4, 1. The location of D is 2, 1. And the location of E is 2, 3. Now let's list the ordered pairs for A prime. Now, if we just sit here and count, we can see 1, 2, 3, -3, -1. But we can do a little bit of math, because since we know it's 6 units to the left, we can say what's 3 and left would be minus. So 3 take away 6 is -3. 4 take away 6, -2. 2 take away -6 would be -4. Same thing's true for going down. Down would be negative, going up would be positive. So let's do that to the original y. If we did 4 and a -5, we get -1. 3 and a -5 is -2. 1 and a -5 is -4. And then we can fill these in as well. So this kind of gives us the ordered pairs and how to find them. Now let's take a look at a second one, which is called a reflection. A reflection is a flip of a figure over a point or a line. Now it's important for us to know that a line of reflection, it separates the image and the pre-image, and they're the exact same distance from this line. Now this line of reflection can be found anywhere. We can put it, just take this one over here if it's going to let me. We can have it going up and down, and it doesn't have to necessarily be on the y-axis. It could be off to the side like this. It could also be going at an angle. It could also be going flat. So we can take a look at a couple different types of lines so that we understand the line of reflection. But the most important thing to remember about this is that they're the exact same distance from the line. These images on both sides of the line are exactly the same distance. So let's take a look at this one here, which I call a y-axis. And we need to know how to write that line. Well, what we want to do is we're going to call this x equals. Because the reason it's x equals is that we notice when it's going straight up and down, there is no slope. In fact, the slope is undefined. Because the slope is undefined, there is no y available to us. So all we have to do is say x equals, and we would put it there. So since it's on the origin, this would be x equals 0. This line right here would be x equals 2. If I moved it to this side, that would be x equals -4. Now, the x-axis, a little bit different. Since it's got a slope because we can walk on it, and here we know that slope is equal to 0. That's why there's no x involved here. We would just take this line, and wherever we would put it, we would say y equals. Here, y equals -3. Here, y equals 1. Here on the x-axis, y equals 0. So we need to know how to name these so that if we're reflecting, we know how to reflect. Let's talk about angled lines now. We're going to concern ourselves primarily with angled lines going smack through the origin and nowhere else. And when we do that, we're going to talk about a line that's y equals x. We can see it's positive. It's got a +1. You can see it's going through the origin. That's why it's +0 over here, going smack through the origin. And it goes up 1 over 1. So this would be the equation for that line. Now going in the opposite direction, as hopefully you have guessed, it would be y equals -x because it is going downhill. So let's take a look at a reflection here. And remember, reflection is a flip of a figure over a point or a line, and that line is called the line of reflection. What we're going to do is we're going to reflect over the y-axis, and we're going to take this figure FGHI, which is a trapezoid, and we're going to reflect it over the y-axis. We can see how it's 1 away from the y-axis, so we would put a point here, and that would be our f prime. We would also go, this is 3 away, we would go 3 away on this side, this would be g prime. 1 away here, that's I prime. And this one is 3 away, this would be h prime. I'm going to take the figure itself, and I'm going to flip it over and match it right up. So we can see how it flips over. And that line of reflection, for us, that line of reflection is right here, which happens to be the y-axis, and that happens to be x equals 0. Now, what we want to do is practice getting some ordered pairs here. So let's talk about F. We'll start there first. That will be 2, 1. G will be 4, 2. 3. And 1, 2, 3, 4. H would be 3 and -4. And I, for this figure, will be 1. And that's where I went wrong here. Excuse me for that. Let's finish I. I would be 1 and -2. F would be +1 and +2. There we go. That looks a little bit better. So now what we want to do is we want to take a look at what f prime would be. So we know that this is f prime here. This is g prime, I prime, and h prime. Let's start with f prime and see what's going on. This is at -1, -1, +2. So what we see is happening that when it's reflecting over the y-axis, all it's doing is taking the values. Let's just take g. This will be -3, +4. It's keeping the same y values, but it is making the x values taking the opposite sign. So we can finish this just so. Okay, so that kind of gives us an idea about reflections. Now let's talk about rotation. Now rotation is a turn of a figure about a point. The turn is counted in degrees and stated by direction. This is called the angle of rotation. So we're going to have different kind of rotations we're going to look at. We're going to look at things that are 90 degrees and things that are 180 degrees. We could be 90 degrees clockwise or 90 degrees counterclockwise. We can go 180 degrees clockwise or 180 degrees counterclockwise. So we want to make sure that we're aware of how far that is turning. Now, when we are using patty paper, which we'll be using here in a second, that's going to help us to show how to turn. Now, for the sake of our discussion today, we're going to be turning about a point. But typically, in most of your assignments, we're going to be turning about the origin. So let's take a look at this figure here, which is JKL, and it's a triangle. And what we want to do is rotate it around the point 2, 3. So what you want to do is you're going to take your patty paper and draw this triangle, and then put your pencil down and hold it where the L is, and then you're going to take it and you're going to rotate the paper 90 degrees. So it's going to be one rotation. When you rotate it once, you should be right there, because we're using that point 2, 3 as our point of rotation. If we were using the origin as a point of rotation, it would have came way down here. Probably been right about there. But we're going about this point, so it's going to be right there. And we'll practice those other ones later. But right now we're going to rotate around this point 2, 3. Now let's find some points for this. We know that J, here located 1, 2, 3, 4, positive 4, and 1, 2, 3, 4, 5, positive 5. K is located at 6, 3, and L is located at 2, 3. Now J prime is exactly the same place as, L and L prime are in the same place because we're using that as a holding point. So that's not going to change. J prime is going to be 1, 2, 3, 4, and a 1. And K prime is going to be 2 and a negative 1. So there's no real correlation with the change. There is a little bit when we go about the origin, and we'll take a look at those when we talk about algebraic representations. Now let's continue and do a 180 degree turn. Now a 180 degree turn from this point would mean that we were not only going to start here at 90, we're going to rotate it even more. We're going to spin it some more, and it's going to take us straight across just like that. And I'm going to color this differently so we can have it stick out a little bit. Some of you guys can use your red pencil if you want to make that a different color. And here, this is going to give us a different set. And this is a 180 degree clockwise spin. One thing you will notice is that a 180 degrees clockwise spin is the same as a 180 degrees counterclockwise spin. So keep that in mind because it's going equidistant back. And let's finish this off by putting in our points for J double prime, K double prime, and L double prime. Sometimes it's good to change the letters once you start moving objects around, and we'll talk more about that in the coming days. So let's put down what our points are. We notice that, again, our L is not changing, right? That's going to stay at 2, 3. But when we take a look here at K double prime, we're at -2, +3. And J double prime is at 0, 1. So hopefully this will kind of give you an idea of just taking a look of what a translation is, what a reflection is, and what a rotation is, and how it all looks and how it all reacts with everything around it.